To all of you, I'm JB.
And I'm Margaret.
And we are here to present to you the Avogadro's Law.
Who is the person behind the Avogadro's Law?
He is Lorenzo Romano Amadeo Carlo Avogadro.
Wherein, in this law, it states that equal volume of all gases at the same temperature and pressure have the same number of molecules.
And 1 mole of a substance is equals to 6.022 times 10 raised to 23rd power. And it is Avogadro's.
Amadeo Avogadro lived in Italy, and his work means an awful lot to chemistry. Amadeo Avogadro may be dead, but we all should remember what he said. Equal volumes of gases at the same temp and pressure have the same number of molecules. Amadeo Avogadro, that's his hypothesis. You got 2 balloons filled with different gases, equal volumes, but they both have different masses. If conditions are the same everywhere, tell me, how do the number of molecules compare? Equal volumes of gases at the same temp and pressure have the same number of molecules. Amadeo Avogadro, that's his hypothesis. Why is his hypothesis so great? You can use it to find atomic weights. It's based on the ratio of the masses of equal volumes of those gases. Equal volumes of gases at the same temp and pressure have the same number of molecules. Amadeo Avogadro, that's his hypothesis. Avogadro helped shape atomic theory, and when I think about it I get sorta teary, 'cause no one believed in what he said till 4 years after he was dead. Now when you speak your mind and everyone ignores you, no one's standing up and rooting for you. So what if they snicker and they laugh? Someday they'll want your autograph. Equal volumes of gases at the same temp and pressure have the same number of molecules. Amadeo Avogadro, that's his hypothesis. Equal volumes of gases at the same temp and pressure have the same number of molecules. Amadeo Avogadro, that's his hypothesis.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your aunt's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you have equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amadeo Carlo Avogadro. Wonder how long it took him to sign autographs. Unfortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists look at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container, or in scientific notation, 6.02 times 10 to the 23rd particles. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind, Avogadro was the first one to come up with this idea, scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number. Now, back to the mole. Not that mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or a 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for
The
that.
formula of this law is volume 1 over N1 is equals to volume 2 over N2. And that's all for today. First exercise problem to this law. 5-liter gas is known to contain 0.965 mole. If the amount of gas is increased to 1.80 mole, what volume will result at unchanged temperature and pressure? First, we divide here.
Second example, a 25.5 liters balloon holding 3.5 moles of carbon dioxide leaks. If we are able to determine that 1.9 moles of carbon dioxide escaped before the container could be sealed, what is the new volume of the container?
Amadeo Avogadro lived in Italy, and his work means an awful lot to chemistry. Amadeo Avogadro may be dead, but we all should remember what he said. Equal volumes of gases at the same temp and pressure have the same number of molecules. Amadeo Avogadro, that's his hypothesis. You got two balloons filled with different gases, equal volumes, but they both have different masses. If conditions are the same every